So we want to see how many numbers are found in each of these different number bases, and then we're going to look at how to convert from one number base to the other. In a subsequent class, we're going to also look at how to add numbers in different number bases, how to multiply and subtract numbers in different number bases, and also how to possibly divide numbers in different number bases. Okay, so that's what we'll be looking at. So first, let's write what number bases are. So number bases So number base refers to the number of digits in a numbering system. So number base refers to the number of digits in a numbering system. Now we're going to look at the types of number bases. Okay, so we'll look at the different number bases, starting from base 2. Base 2 is also called binary. Binary. Bi means 2, just as we have bicycle. So base 2 is also called binary number. Binary numbers or base 2 numbers consist of 2 numbers. Remember, number base system refers to the number of digits in a numbering system. So when you're talking about base 2, we are referring to a system that has only 2 digits, and those digits are 0 and 1. So in that numbering system, we only have 2 digits, which are 0 and 1. So we don't have 2, we don't have 3, we don't have 4, we only have 0 and 1. So this is the numbering system used by our gadgets. Computers use base 2 numbering system. So for those that want to go into computer science or coding and all that, this topic is a foundational topic for you. Okay, so we have base 2, which consists of 2 digits. We have base 3, consisting of 3 digits, 0, 1, and 2. We have base 4. Base 4 consists of 4 digits, starting from 0, 1, 2, and then 3. Okay, and then we have base 5, 0, 1, 2, 3, 4. So we can continue until base 10. Okay, so I'm going to skip base 5, base 6, base 7, base 8, and base 9. So base 10. Base 10 numbering system consists of 10 digits, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have base 2, base 3, base 4, base 5, we have 6, 7, 8, 9, and then this is base 10. So our target, the first thing we're going to learn how to do is how to convert from one base to another. Why is this important? Let's look at a situation. I want to do a calculation with my phone, right? What I know, my own numbering system as a human being is the base 10 system. The base 10 numbering system starts from 0 to 9. So any other number we can generate is a product of these 9 numbers. So if I say 1522, it's a combination of 1, 5, 2, and 2. So this system is what combines to produce any number I can think of. But if I'm working on base 2 system, I cannot have 2 in it, I cannot have 3 in it, I cannot have 4, 5, 6, 7, 8, 9. So my computer uses, or my phone uses base 2. This means my phone does not understand what 2 is, does not understand what 3 is, 4, 5, 6, 7, 8, 9. So when I impute a value, let's say I want to multiply 520 multiplied by 18. My phone does not know what 5 is, does not know what 2 is, does not know what 8 is. So I've given the phone a task to do 520 multiplied by 18. Now, for this phone to understand what to do, the phone has to convert, or there is a conversion system in the phone to convert this question I asked. This is in base 10. So that conversion system has to convert from base 10 to base 2. And then the phone is going to understand, or the calculator in the phone will understand, okay, this is what I am supposed to do. This will be converted to base 2. And then the computer or the phone will understand it and solve. But if the phone wants to display the answer, the phone cannot display the answer in base 2 because the answer will be in 0-1 combination. So the same conversion system is going to convert it back to base 10 before displaying the answer. So what we are trying to learn is what goes on behind the scene when a human being and a gadget are interacting. So when you are interacting with your phone or your calculator, this is what is going on. You ask questions in base 10, it is converted to base 2, the computer solves it and brings it back to base 10 for you to understand it. So that is what we are going to look at, how to convert numbers in base 10 to base 2. And then we're also going to see how to convert numbers in base 2 or any of the other bases to base 10. Okay, so let's go ahead to do that. I hope you guys understood what I was saying. We're going to see how to convert from base 10 to other bases. So converting from base 10 to other bases. So let's look at the first example. So let's see how to convert from base 10 to base 2. In this particular question, we are converting from base 10 to base 2. So we are converting 36 base 10 to base 2. So when you are converting a number from base 10 to any other basis, you are going to divide the base 10 number repeatedly by the base you are converting to until you get to 0, until you break it down to 0. So let's look at that. So you're going to divide 36 by 2. So we have 36 being divided by 2. So whenever you divide, you are going to take note of the remainder. What remains after you divide? So you have 36 divided by 2 is going to give us 18. So you have 18. When 36 is divided by 2, you have 18. Is there going to be any remainder? There will be no remainder, so we're going to write remainder 0. So remember we are dividing repeatedly by 2. So we have 2 here. 18 divided by 2 gives you 9. Will there be any remainder? No remainder, so we have remainder 0. Going further, we continue by dividing by 2, so we have divided by 2 here. So 9 divided by 2 is going to give us 4, so we have 4. Will there be a remainder? Yes, so remainder 1. So we'll take note of the remainder. We'll continue dividing by 2, so we'll have 2 here. 4 divided by 2 gives you 2. Would there be a remainder? No, so remainder 0. Going further, we divide by 2. 2 divided by 2 gives you 1. Will there be any remainder? No, so remainder 0. So is this our final, is this where we're going to stop? The answer is no. We are going to break it down until the number here is 0. So here we have 1, so we still need to go further. So we divide by 2. 1 divided by 2. How many 2 can we find in 1? None. So that means it's 0. We have 0 and remainder 1. So if 2 boys are given 1 orange to share, and they are told that each person has to take 1 orange, it's not possible for anybody to take, for 2 persons to share 1 orange and each person will get 1 orange. So they are going to get none, and then the orange will be left there. So 1 divided by 2 is 0, remainder. So that's why we have that. So now we are going to write our answer. So this arrow tells us that we are going to write from bottom to top. When we are writing our answer, we're going to write from bottom to top. So this means 36 base 10 is equal to 1, 0, 0, 1, 0, 0 base 2. 1, 0, 0, 1, 0, 0 base 2. If you observe carefully, you discover that this base 2 number only contains 2 digits, 0 and 1. So there are only 2 digits in this base 2 number. The digits are 0 and 1. You can't find 2 there, you can't find 3 there, you can't find 4, 5, 6, no. The digits are 0 and 1. So next, we are going to see how to convert this same digit 36 base 10. Let's convert to base 3 and let's see what the numbers will be. At the end of this video, I'm going to leave a classwork on the replay, because this video I'm going to post it on my YouTube channel. So if you go over to my YouTube channel and you watch this video to the end, there will be a classwork there. Okay, so you stand a chance to be one of the lucky winners for this class. I'll be giving out $5 to someone who will get the answer from the classwork. So it will be 3 questions basically for the classwork, and then if you get the 3 questions, you leave the answers in the comment section of the video on YouTube, and you stand the chance to win $5. Okay, so let's continue. 36 base 10 we are converting to base 3. So we have 36. So since we are converting to base 3, we are now dividing by 3, not 2. Okay, you divide by the base you are converting to. So base 3, so we are dividing by 3. 36 divided by 3 gives us 12, remainder 0. Remainder 0. And then we divide again by 3. 12 divided by 3 gives us 4, remainder 0. We divide again by 3. 4 divided by 3 gives us 1, remainder 1. And then we've not gotten to the last point, because we need this last digit has to be 0. So we divide again by 3. 1 divided by 3, there is no 3 in 1, so we have 0 and then remainder 1. Okay, so 36 base 10 is equal to 1100 base 3. 1100 base 6. Let's convert 80 to base 6. So let's see if we're going to get the same answer here or something different. So we have to be 6, 80. 80 divided by 6, what do we have? 80 divided by 6, you have 13, remainder 2. And then 6, 13 divided by 6 gives you 2, remainder 1. And then 2 divided by 6 gives you 0, remainder 2. Okay. So That means 80 base 10 is equal to 212 base 6. That gives us the answer. So we want to convert 0.0625 base 10 to base 2. Okay, so let's see. Now, let's look at the contrast between whole numbers, converting whole numbers in base 10 to other bases, and converting decimals in base 10 to other bases. When we are converting whole numbers in base 10 to other bases, we were dividing by the base we are converting to, right? But when you are converting decimals to base 2, instead of dividing by 2, you will multiply by 2. So that's the difference. When converting whole numbers to other bases, you divide by the base you are converting to. But when converting decimals to other bases, you multiply by the base you are converting to. Okay? So let's see how that is done. So now we have 0.0625. We are converting to base 2. Sorry. So we write the decimal numbers 0.625, and then this decimal point we put it here. Okay, so any value that will come here will become a decimal value in base 2. Okay, any value that will be here under this decimal point will be the equivalent of this in base 2. So as I said, instead of dividing by 2, you repeatedly multiply this by 2. So let's look at it. 0.0625 multiplied by 2, what are you going to get? 0.0625 multiplied by 2. So we are multiplying this by 2. Instead of dividing by 2, we are multiplying by 2. So 0.0625 multiplied by 2. What will you get? Can someone do the multiplication and tell me? 0.125. Okay, so do we have any whole number? We have 0.125. So here, the whole number here is 0. So what we are looking for is the whole number. The whole number here is 0, so we are going to write 0 here. And leave the rest here in this decimal column. So 125. So when you multiply this, you are going to get 0.125. So this 0, which is in the whole number column, comes here, and these values at the decimal comes here. And then you multiply again by 2. So you are multiplying 0.125 by 2. What will you get? 0.125 multiplied by 2. 0.25. Let's maintain this 0 here. Let's maintain 1, 2, 3, 4 digits. 1, 2, 3, 4. Let's maintain it like that. So when you multiply this by 2, you're going to get, let me write it down, 0.1250 multiplied by 2, you're going to get 0.2500, right? So this 0 comes here again, and this comes here, 2500. Okay, and then you multiply again by 2. Our target is to make all the numbers here to become 0, and then to get a value here. But we want to make all the decimals to become 0. So when you multiply 0.2500, what are you going to get? Someone is asking why 2500. This is when you multiply 0.1250 times 2 give us 0.2500. So this the whole number we had 0.2500 when we did 0.1250 multiplied by 2. So when we multiply this, which is this, we got this 0.2500. Okay, yeah, we decided to maintain 4 decimal places. So although it is 25, we added 00. So it's the same thing. 0.25 and 0.2500 is the same thing. So now we are multiplying this 0.2500 by 2. What are we going to get? 0.2500 multiplied by 2. What are we going to get? Okay, someone said 0.5000. Good. So 0.5000. Good. And then we multiply again by 2. When you multiply this again by 2, what do you get? Good. So we have 1.0000. Now we've gotten something we are looking for. We've gotten a whole number and the decimals are now 0. So we can stop here. We've gotten a whole number and the decimals are now 0. We can stop here. If you decide to multiply by 2, you keep getting 0, 0, 0, 0. You won't get any other thing, right? So this is where we can stop. So that means when we were converting whole numbers, our arrow went up when we are converting whole numbers. But when we are converting decimal, everything is the opposite. Our arrow comes down. So that means 0.0625 base 10 is equal to, there's a point here, so that means it is 0 point, so it's 0.0001 base 2. How did you get 2? You can't get 2000. Remember, base 2 numbers cannot have 2. So if you multiply again by 2, you're going to have 2 here, which is not possible because base 2 number cannot accommodate a 2. Let's look at another example. I think that should be the last one for today. Okay, I think I've seen one example. Okay, so let's convert 0.375 base 10 to base 5. Let's convert that to base 5. So this is a decimal, so we are not dividing by 5, we are multiplying by 5. So we have 0.375. 0.375. So we will be multiplying by 5. So that means 0.375 multiplied by 5. What will we get? 0.375 multiplied by 5. What are we going to get? Okay, so we have 1.875. So the 1.875. So the 1 is a whole number, so we're going to write it here, 1. And then we're going to write 875. 875. Hope you guys understand. The 1 on this side and 875 comes over here. Of course, you can use a calculator. So once you've put the 1 over here and you want to continue multiplying by 5, so when you're multiplying by 5, you are not multiplying 1.875, you're multiplying 0.875 times 5. So what you keep multiplying by 5 is this part, apart from this whole number here. So we are assuming we've taking note of this whole number, so we continue multiplying by 0.875. So 0.875 multiplied by 5, what do we have? 4.375. So we write, so it gives us 4.375. So we write 4 here, and we write 375 over here. So if you multiply again by 5, we observe something here. Just by doing this now, we're observing that we're going to have a recurring decimal, because we're going to write 0.375, which was what we started with, right? No, we are not going to multiply 4 points. No. Once you've written this down, we are going to start with 0.375. We are not multiplying by 4.375. We are going to multiply again by 0.375, which will also give us this. So we are going to have 1875. So we are going to see that we'll be having a recurring decimal. So if you multiply by 5 again, you're going to have 4375. So once you see that it is in this form, you don't need to bother continuing. You can just stop at this point. And then your answer will be 0.375 is 10 is equal to 0.1414, and it continues. Base 5. So what we are actually doing is we are going through the textbook I'm using is this textbook. I don't know if you guys can see it. I'm using this textbook. So we are in my WhatsApp group. We are going through this textbook for SS1 from the beginning of the textbook to the end of the textbook, and then we go to SS2, SS3. Then, if we are done with that, then we look at further maths. So that's the journey we are taking this year. Our classes Wednesday, Friday, Monday, 8 p.m. Nigerian time on TikTok. So you can join us 8 p.m. If you miss the class, you can always watch the replay on YouTube. Okay, that's why it's also important to check out my YouTube channel, because I always post the replay of the live class on YouTube, especially those that have exams to write this year. Okay guys, so this is the first topic from this textbook. We are actually starting today. So on Friday we are going to look at how to convert from other bases to base 10. So we've seen today how to convert from base 10 to other bases. On Friday we're going to look at how to convert from other bases to base 10. Okay, thank you guys for being here with me up to this point. I really appreciate your presence. We'll see in the next live class, 8 p.m. Nigerian time on Friday. Have a wonderful evening, guys. Bye.